Nearly everyone has heard of AI, but a lot of people are unclear with exactly what it is and what it can do. In this video, we will introduce what AI is and give you a better understanding of how they learn, think, and view the world. Nearly all of the modern advancements in AI come from a field called machine learning. As the name suggests, the field studies how to build computer-based methods that learn, as opposed to more rigid traditional ways that require a set of instructions which detail how to complete a task. These are called algorithms. Let's look at the example of playing a game of chess. You can imagine the problem of creating an AI to play chess. Without machine learning, this problem can be solved using an algorithm. One way to do this would be to assign a number to every possible configuration of the chessboard. We then design a set of instructions for selecting which move the computer should take based on these values. In machine learning, we aim to let the computer learn on its own what the best strategy to win is. So what is machine learning? In order for the computer to learn its own way of doing things, it will need a way to process incoming information and transform into something useful for its task, something like our brain. The backbone of nearly all modern systems are called artificial neural networks. This is how AIs think. It is their brains. Now let's consider some of the types of tasks that we need an AI to do. Remember, a task is a problem that we wish the AI to solve. This could be playing chess, driving a car, summarizing articles, optimizing traffic, creating art, handwriting recognition. How we design and interpret the numbers that go into and get back from the neural network will depend on the task we are trying to do. Let's look at an example of how a machine would learn to solve the task of recognizing digits handwritten by a human. As an example, we have this number 8. For a computer to interpret what it is seeing, we will have to find a way to represent it using a series of other numbers. One way to represent this problem is to look at each pixel that makes up the digit. We can use a number that corresponds to a shade of gray. For example, black pixels will have a value of a 0, white pixels will have a value of 255, and every other shade of gray will be assigned a value in between. In the end, the computer will see a grid of numbers that it can use to help determine what was written. In our example, this grid of numbers has a total of 784 values. These are the numbers that will be passed into the input layer of our AI's neural network. We can see that this information is passed through the network and is getting transformed into one of 10 possible digits in the output layer of this network. This is the AI's guess as to what number was written. Initially, an AI has no idea what its input is and what output it should be providing or what task it is even solving. In our last example, the network could receive a number 8 but guess that it's a number 2. In order to actually teach or train our AIs to perform a given task, we need to decide on what method would be best to do so. Two very famous examples are supervised learning or reinforcement learning, but there are also many more. In supervised learning, the AI learns from labeled examples or data. The AI makes a guess, then it checks the data to see if its guess was correct or not. and then we update the neural network to be more correct for the next input. The key takeaway here is that we are having the AI learn from examples, and the more examples we have, the better. In reinforcement learning, an AI learns from interactions with its environment. First, the AI performs some action and then checks the state of its environment. In chess, we would say that moving a piece is an action and the resulting board is a state. The AI receives some reward, which we can view as positive or negative feedback. Then we update the neural network to take actions that maximize that reward. Unlike supervised learning, which learns by example, AIs trained using reinforcement learning do not learn from examples we provided, but instead from interacting with an environment. So how does an AI view the world? AIs view the world very differently from how we do. So we can't fall into the trap of projecting human qualities and intentions onto them so easily. Let's see one last example of how this is done. Mathias Babin is a student at the University of Western working on his PhD in the field of artificial intelligence research and computer science. Here, he will provide an overview of a simulation he is creating to demonstrate how AIs think and learn.
Hi, everyone. So what I want to show you all today is a little example that we've made on how AIs actually see the world, and we'll have a good visual representation of what's happening here. So in our little scenario, you can see that we have this little robot that can walk around with all these different types of terrain. And what the robot can do is it can go and it can plant little trees into the grass. What I want you to notice is in the top corner, we have this reward. So this is an instance of reinforcement learning. Previously in the presentation, you saw examples of supervised learning, reinforcement learning, and we alluded to how in reinforcement learning, AIs receive a reward from interacting with the environment. So here, the AI interacts with the environment by planting trees, and we get a reward for doing so. And in this case, the AI is rewarded for planting trees in better ground. So if we planted in this lush soil, you'll see our reward went from 1 to 3. So it gained 2 reward for doing that. But if it plants it in very infertile ground, like in these rocks, the AI is not going to receive a reward at all. It will actually stay at 3. Right? So if the AI's purpose is to maximize reward, it should learn to plant trees in fertile ground like this grass here. Okay, so this is a pretty simple task. I feel like if any human had to do this, they would pretty quickly learn how to do this. So for us to gain at least an understanding or appreciation for why it maybe takes AI a little bit to learn, or what the AI is even seeing, we have a few different representations of this exact same task. So if we take a look at a more abstract representation of this, right, where now instead of having all these different types of grass, we just have these colored blocks, it all of a sudden becomes a lot more difficult to know where we have to plant things. In fact, we actually have to experiment. So what happens if we plant something in the green? It seems like we get a reward of 1. Maybe let's try it somewhere else, like this purple. Okay, we didn't receive a reward at all. That means whenever we plant in red, we gain a reward of 2. So for us to learn this environment, we should be planting as much as we can into the red tiles. A little more of experimentation needed there, but we did learn the task pretty quickly. Now let's see how the AI actually views this world, right? Because in our case, the AI doesn't have any cameras, it doesn't have any sense of what the environment is. All the AI has are these numbers which describe to it where its position is in space. So this is an X value and a Y value. And then this last number is just describing what type of tile is above. So what I really want us to learn from this or take away from this is, while we look at other tasks like planting things or we might even think about things like self-driving cars or playing chess or any of these fun things, it's actually a really difficult task to convey to a computer. In this case, we have to convey it through these three numbers here. And to really make this a bit more concrete, I want to show you what these three numbers look like in our environment that we're used to seeing, right? Where you can see these exact same numbers are being represented over top of our AI, right? Whenever we're on top of grass, this number will be 0 at the end. Whenever we're on top of rock, it will be 2, right? And then whenever we go up and down, that's our Y value. Left and right will be this value. So we can see how we can actually represent everything here with just three numbers. But as humans, we like looking at the task of, we recognize grass and rock and these trees, and we can see the AI moving. But this is not something that the AI itself doesn't even know what task it's performing. We just put it in an environment where, it sees these numbers and it has to figure out what to do. So it's a very complicated thing, actually. Like, it's a pretty monumental task that we're asking these AIs to do, and it's pretty miraculous that they are actually learning from it. So the last thing here that I really want to convey is that before we make the mistake of, ascribing human qualities onto AI, or especially human intentions onto AI, it's very important for us to remember that the AI has no idea really what our world is. Its whole world is just a series of numbers like this that we're setting up scenarios for it to accomplish a task that we want. It's really a tool that helps us accomplish whatever tasks we're training it for. In our case here, we wanted to train it to learn to plant plant trees in the most efficient manner possible. So I built a representation that would help the AI learn to do that. But for a different task, it could be a completely different representation. So that's the main thing I wanted to show you, and thank you so much.
So as we enter a new era of artificial intelligence, remember, like any technology, this is just a tool. We need to make sure that we as humans steer it towards applications that are helpful to us and move away from those that ultimately would cause harm.